Alright, today we're going to focus on a specific type of compound called a hydrate. This is a crystal compound in which ions are attached to one or more, leave you in suspense for a moment, one or more water molecules. They have a specific ratio of water to what we would call the salt. We'll talk about that in just a second. So here we have this salt, sodium carbonate, and we're going to be attaching these 10 waters. Now, important to note, this is just the symbol for a hydrate. It is not a multiplication symbol. Just because it's really important, because when we go to calculate GFM, we do not want to multiply the mass of the salt times the mass of the water. So water is built right into the structure. Substances without water, which is a lot of the compounds we work with, we say is called anhydrous. We can actually cause this hydrate by heating it to become anhydrous and driving the water out. And that allows us to actually do some neat calculations where we can then calculate what's the ratio of salt to water. So to do these calculations, we need to be able to specifically calculate the GFM of a hydrate. So in order to do this, it's going to start off as a normal GFM. So I'm going to go ahead and do 2 times the mass of sodium, which is 23.0, plus the mass of 1 carbon, which is 12.0, plus the mass of 3 oxygens, which is 16.0, plus I like to personally calculate the mass of the water. So we have the mass of water is 18.0 grams based on the 2 hydrogens, 1 oxygen. You can split this up into hydrogen and oxygen. I just very often have students that forget that in this case there would be 10 oxygen. So I just find it's easier to say I have 10 waters and the mass of water is 18.0 grams. And by doing that, I calculate that the entire mass is 286.0 grams. So that's the mass of my entire part. And again, it's important to know that this is really, think this is a plus sign. You're adding the water to the mass of the salt. Right. So now we're going to do that by going ahead and calculating the mass of the water. So let's just recall from the last slide, we found that the mass of this was going to be 10 times 18, which was equal to 180 grams. And we know that the entire hydrate, which we already did, has a mass of 286.0 grams. So we have part over whole times 100, so same calculation as our previous section on part over whole times 100. Then we're going to plug in our water. So we have 10 waters, which is 180 grams, divided by the mass of the whole compound, which is 286.0 grams, times 100. And then our final answer here, you should get 62.9%. Okay, so really just continuation of the last couple of sections in the notes. So here, if you want to pause it and then try this out on your own, I'm going to kind of quickly go through the masses that you should get. Okay, this is going to be 2 times 18.0 or 36, and then the mass of the entire hydrate is going to be 244.3 grams. So when we go ahead and do part over whole times 100, we're going to fill in our 2 times 18, which again, 18 is just the mass of the water. And then our entire hydrate's mass, including the water, make sure you show that times 100. And when you plug that in, you get a smaller percentage here of just 14.7%. All right, let's look at how you're going to have to go about solving some data. So here we have a 3-GAN sample of a hydrated salt. So this is going to be considered the whole hydrate, okay, which includes both the salts and the water. And it's heated to a constant mass of 2.32 grams. This amount is specifically the anhydrous salts. So what it is without water. Now our part is going to be the water. So our part, which is the water, is the amount that evaporated out. So when we find the mass of the water, we actually have to do first, that should be 3.0, minus the amount that was at the end. And by subtracting those two, in which we get 0.68 grams, that's how much water evaporated out. So this is water evaporated out after heating. So when I go to do my part over whole times 100, I need to make sure I put the 0.68 grams on the top, and then on the bottom, we always want to have the whole hydrate, which was our original starting amount, which was 3 grams. We still want to make sure we're showing that times 100, and when you calculate that, you should get 22.7%. All right, go ahead and try this one out. Here, this 5 grams is going to be the whole hydrate. This here is going to be the salt. Okay, so to find the water, we have to do our 5 grams minus the 1.85. So we get 3.15 grams of water. I'm going to do part over whole times 100 again. So again, our part is that mass of the water divided by the original mass of the entire hydrate, including the water. And that should be a G. When you go ahead and do that, you get a larger mass of 63.0%. All right, so that's it. So really, again, this kind of combines a little bit with GFMs, percent composition, and then just a little bit more knowledge about what a hydrate is.